something that can parse. So what we started with last time was like a really basic subset of Rholang, right? And so I thought maybe a good first goal was something that can parse a simpler grammar, which is just the row calculus. So we don't have all of those ground terms like integers and tuples and, you know, all of that stuff. The only ground term is nil. And then, so maybe a good goal for today would be to write a parser for nil. That one seems like it might not be too hard. And then see if we can get to parse like at nil, bang nil.
Oh yeah. Maybe this is too easy.
Is it? Oh, okay.
Yeah. I'm thinking that.
Maybe for you.
No. I mean, for last time we made a parser for send, and this is all like almost the same.
Yeah, that's right. So that's why I thought maybe it would be a good jumping off point. Like we'd have to write a parser for nil. We'd have to modify our parser for send, and then if we got time, yeah, great. Let's try a receive or whatever.
Oh, no. I was thinking that now we need this alternative operator or I mean combinator.
Okay. What is it?
You want to check if this is like a send channel or it's receive. But they are both Rholang terms, so they both must have the same type. And you're checking this term or this term.
Okay. So what are the two terms now?
For example, for row calculus, we are parsing like a Rholang term or Rholang expression. So we can this pipe signal in BNF is really like an OR.
Oh yeah, totally. I mean, so we'll need to do that to add a nil. Like, so we can make like nil parser, send parser, and then like we have something called like process parser, right? That tries nil or send, or how does that work? I'm not really sure.
Yeah. Let's start from the last.
Okay, cool. Yeah, I think, you know, for me, because this is new and it sometimes is a lot to process, I wondered if we could like restrict ourselves to just row calc. So, you know, only one ground term of nil, no bundles, no joins, you know what I mean? Stuff like that.
So let me share the screen.
I was hoping you guys were going to be doing more parsing stuff, by the way.
Oh, nice. Yeah, me too. I've done a little bit of homework too, Tomislav. I finished my brainfuck interpreter, and I watched a ton of monad videos and tutorials and stuff. So I think I'm starting to get comfortable there.
Oh, cool. So is it big enough or
maybe one more? Yeah, it looks good.
Yeah.
So what I was saying is that we made this data type.
Right.
And so and we made only one data constructor.
Right.
So we want to say this is not the only way to define a Rholang process. This also can be a nil.
So if it's nil, we probably don't want to call it send though, right? We should call it like proc or something.
Yeah. Maybe this is like a better.
Yeah. Okay. Nice.
Mm-hmm.
Or maybe we can do something like this. Send or nil.
Yeah. Great. So you can nest it like that?
Sorry?
So let's see. So my understanding though is like, if I want to make a proc, I now have two constructors, nil or send, and neither one of them is parameterized in any way.
Yeah.
Because like before when we did, like on line 16, send const is a constructor and it's parameterized, right? Or am I looking at that wrong? It's
And
got a
now,
string.
and here I'm using the like a this
Okay.
type as one of valid values for this data type.
Oh, I didn't realize you could do that. Oh, that's great.
Well, now I'm not sure that this is correct because yeah, you're correct. This is like a data constructor send. I must say something like this. Yeah, you're right.
Oh, now it takes, okay, so now we can construct a proc with the tag send, and it's parameterized by including one of those actual sends that we defined on line 16.
Yeah. You're right. You're right.
That makes
I
sense.
can't just say yeah. You're correct. Sorry.
No, that's okay. Yeah, I'm glad we're learning.
Wait. So the first send is the constructor, and the second send is like a name for it.
It's the first send is the name of the constructor, and this is like a one parameter to this constructor.
Yeah. Okay.
But now I'm thinking that this is like too confusing. It's much better that we can see, have like a simple type. Better than this constructor send.
Okay, cool. I dig
So
that.
that's a little bit different than BNF, right? Because you should just be able to throw the one data type inside the other in BNF.
Totally.
Yeah. You're not specifying the name of the constructor. And,
Yeah, exactly. Okay, cool.
But now this is not completely correct.
You gotta change all your sends to procs
Oh,
now.
yeah.
And I mean it's not completely correct, but because we are assuming that this will always be a send.
Oh yeah, not that it can also be a nil, right?
This can be a nil. So but maybe now we must make this as
Okay, so real quick, remind me, what are lines 39 and 40 again?
so
It's a function?
this is
That's our parser.
This is our parser
Okay.
for sending. And now I'm thinking that the name is not correct, and
Yeah, right.
so what to change?
I mean, how about like parse row?
Yeah, I'm thinking that
Or parse proc or something.
maybe I can remove this or.
So I think I'm misunderstanding something. Is it not just a matter of typing different characters that are a better word than send? Is there actually some like compiling problem here?
No. I'm just thinking that to not be so confusing, because we have a parser proc, but we are parsing only send. So we can do something.
So we're gonna have to rewrite the parser, right?
Yeah, and I'm thinking maybe we can just parse. We don't have like a separate constructor for this, so.
Oh, I think I'm starting to see what you're saying. I wonder if
I can change the names and makes parser like this.
Okay.
And we can parse. Well, we don't. We have everything we need. A string is a parser for a concrete string that we want to parse. We can just say, okay, we want to find this text.
So where did?
But we need to use this nil constructor. So I want to use now a different combinator for a functor. So because we have a constructor for proc which doesn't accept any parameters, and here we have a string parser that returns string that he parsed. But we know we parsed nil, and we don't need this argument, this string argument. So we want to just say, okay, we want to map over this nil constructor, but we want to ignore the input parameter. So we can say this is a nil constructor mapped without taking care of the argument. This is the type. Give me the type. Where he's showing the type. No, I don't see the type. I want to show you what is the type. No.
So is stack REPL? Oh, I've read a lot about Cabal too, by the way. Is stack REPL different than just like GHCI?
No, it's practically the same.
Okay.
But when you use directly GHCI, you're not using dependencies in your project. So you must load files or something like that. But when you use a stack REPL or Cabal new REPL for now, then you have you're using it in the context of your project. So you can load files from the project.
Okay, so I just went to my home directory and typed stack REPL, and it tells me like warning implicit global project config. But if I had run that in an actual project directory, then it would have like loaded all of my dependencies based on my like whatever the package.yaml or whatever, stack.yaml.
Yeah, and the references for the project is in Cabal file.
Okay.
But stack is using a package YAML to generate Cabal, so you have like a nicer way to write dependencies. Because if you see Cabal, it's much longer and much more verbose.
Okay, so that makes sense. That makes sense. Hey, I've got another question for you. I cloned your repo, this repo, and I ran whatever commands you typed in the README. Something about stack, and can we flip over there real quick actually to the README? So I did stack build. Yep, and or actually I think I did Cabal new build. I don't remember.
Oh, but you cannot use Cabal until first stack command.
Oh, then I must have done stack because whatever I did worked. But my question was, it downloaded like 2 or 3 gigabytes of stuff. Is that what you expected?
Oh yeah, and this is why I'm using always the same version of Resolver, because I want the same snapshot that uses the same GHC that I have already on my global installation with the Haskell platform.
Okay.
Because stack is very nice. You can use like every GHC version you want. You just say, okay, I'm using this snapshot, and he knows he will download exactly this version of GHC and all of these packages and in this version. And if some package is missing, for example, in this snapshot, some packages maybe is not included because they are not aware of it or it's not transformed for this version or something. You can specify extra dependencies from different sources that are not included in this snapshot.
Okay. So maybe what happened is like I have some version of GHC installed on my computer that I got through the Debian package manager, and it happens to not be the same version of GHC that's in your like LTS 12 whatever version we're using. So when I did stack build on this repo, it was like, well, you don't have the right version of GHC that stack.yaml says you need, so it downloaded the right one that you required here.
Yeah, exactly.
Okay.
And I'm using 843, but I seen that now the Haskell platform moved to 863, I think.
Okay.
So, but yeah, I didn't install it.
Okay. Cool.
But you can check which snapshot is like ideally for you, but so you can change this number. And
Okay, cool.
but
Yeah.
and I heard that like this new build is like a much better than old Cabal, and yeah, I definitely want to use only Cabal without stack if this is possible.
Oh yeah. Okay. Cool.
But my plugin for Visual Studio Code is using also the same version of JC. So this is also the problem, because this Haskell IDE engine, I think, it uses a stack, or if doesn't find stack YAML, it uses the old Cabal.
Okay.
So this is why I'm using stack in Visual Studio Code. So this.
Okay.
This
All right. Cool.
IDE language server is working. And can I say now that maybe Isaac, you're looking for this kind of thing for Rholang IDE, because I was thinking how to build like a good support for Rholang, and very good ways to create a language server that is built for Visual Studio Code, but now is also used for different other editors. Also on the web directly, or inside the editors. Mm-hmm. So you can probably use this Haskell IDE engine, this language server for Atom also, and for Sublime Text.
Okay.
So maybe we can build this language server and just have all the editors working for Rholang.
Mm-hmm.
Okay, so take one step back here. What is it exactly that you're describing? We're going to build some centralized like web server that hosts like syntax highlighters and linters and stuff for various editors.
Yeah, and let me see. Oh my God. I have an example that I made a long time ago. I was thinking of something like this. Yeah, maybe it's not everything's so relevant now, but this is how I imagine this language server. Is this big enough?
Yeah, it's big enough. I can see it.
So we defined this language server, and we can communicate with different editors via the RPC, because the language server is using RPC protocols, and we can have some kind of our API with sockets, and we can support like web browsers and whatever we want. This is here. I built this with a Rosette because we didn't have like a Rholang working. And I can show you the code because it's not too complicated. How is it's starting? Maybe you remember we use this Rholang CLI.
Yeah.
So I'm starting here the Docker, and I'm sending this via sockets to this Docker container, and from the browser. And this is like an example for Monaco editor that is used in Visual Studio Code.
Okay.
I mean editor. I mean like this text editor. This is what I mean.
Yeah. Okay.
Yeah, but I want to say that all of these things is like it's already existing. We just need to implement this intermediate step.
So what is the like end goal that you're describing? Like, so let's say we do the thing you described now. What can internet users do that they couldn't do before?
Well, if we have more data from a Rholang compiler, we can make something like this. If you write something wrong, we can make this squiggly line and make this tooltip.
I see what you're saying. I see. Okay.
Nice.
Because with the language server, you have interface for the editors.
Okay, so the language server is giving you back ambiguous type variables S0, M0.
Yeah, and you can say to this language server, okay, find all references, and you implement this on the language server, and you can give the language server, okay, this name has a reference in this line number and column number.
Yeah, yeah.
So you can point the user, so you don't have to code everything yourself. You can just give the list of references to the language server, and he will show user how to navigate to these references.
Yeah, okay. Okay, that's starting to make sense. So you're saying server, is it actually on the network? Like if you turned on airplane mode, would you no longer be able to use this stuff, or is the server running locally?
The server is running locally.
Yeah, okay.
This Haskell IDE engine is running locally, and I'm seeing output from this.
Oh, so okay. So VS Code starts it up for you at the right time.
Exactly. When I first opened the Haskell file, or with the Rholang, when I first opened the Rholang file.
Yeah. Okay. So when it detects that you're editing some particular kind of file, it does all the fancy things for that particular grammar, like starting the server and syntax highlighting and stuff like that.
Yeah. And finding the project Cabal file, download the dependencies, and all these things.
Yeah. Okay. All right. Cool. Yeah. So I get that idea. I think I'm still interested in learning how to do the parsing, because my feeling always when I think of like, oh, let's integrate something cool with Rholang is like, oh, well, we're kind of at the mercy of the Archain dev team for like what goes into the interpreter. Like if it has to give us detailed information back, they would have to do that, and they have their hands full with trying to reach a certain number of COM events by March or whatever it is they're doing. So I guess I'm kind of coming out on this a little bit now. My goal is to build a totally alternative Rholang interpreter so that we can sort of hack and do these fun things that like you're describing now.
Okay, but in respect to parser, we can use we can generate parser in Haskell. We don't have
I'm
to.
interested in that too, like from their CF, their BNF.
No, from the protobuf.
Oh, yeah. I mean, show me whatever you want to show me.
But, but if you want to parse the code, this is like for communication, but okay, but I can show you this library that I found interesting.
Yeah. So so I should tell you, this is something I did the other day too. In the Archain repo, there's a BNF for the Rholang grammar, and supposedly you can compile it and use it with Parsec, and I tried to do that, but I ran into some trouble.
Wait, where did you say that was?
Yeah, I didn't try it. Yeah, and maybe it's a kind of syntax error.
Yeah, I got a syntax error. Yeah.
Where did you say it was?
So you're talking about the grammar file, Isaac?
Yeah.
Let me just dig up the link real quick.
Okay.
But interesting. What is interesting they are using a Haskell library BNF to generate a BNF in the Archain repository.
That's what I thought, and so I was like, oh, maybe that would be a cool thing for us to get on.
Yeah, I never tried it.
I tried it, and I only tried it once. I tried it totally out of my league, just saying like, oh, maybe this will just magically work, and it didn't, and I haven't gotten to debug it yet. But it might not be that hard. So like,
I pinned it to the Rholang channel.
Oh, nice. Thanks, Jim.
Oh, sweet.
So I installed BNFC, which is like the BNF compiler, and I gave it that Rholang mercury.cf file, and it output a bunch of stuff and said something like, oh, and so I ran like BNFC dash dash target Haskell, this particular grammar file, and it gave me a bunch of output and a bunch of new files, and it said like you have to run another program called Alex on this one output file. Well,
Oh,
I don't know how deep you want to go into it.
well, I'm not too familiar with
Yeah,
all of
okay,
these
okay.
things, so yeah, yeah.
Cool. All right, so you were going to show me some library you found?
Yeah, but this is for protobuf.
Oh, that's good to know too, though, because if we want to re-implement more of the RChain stack, like it would be nice to still reuse their protobufs, you know?
Yeah, and like this is very nice library. It uses lenses, so you don't have to specify all of these types. You can just uh, like in more imperative way specify a schema of the type. But
Okay.
it's more difficult to use this lens library. Is there any example? Yeah, but it's not. Maybe better not to talk about it now.
Okay, yeah, that's cool. That's cool. So maybe we can try to just parse nil and send like we were thinking.
Yeah.
Cool. Okay. That's good. I'm down for wander, like just thought sharing too, you know? All right, so
Now I have some errors, but I first want to show you this type for this combinator. It's like a map. This is a map, and it's
okay, so that one takes an A to B and an F of A. That's kind of, oh, this is kind of like the map I'm used to. F means list.
yes, exactly. List maybe either promise whatever you want.
So all of those things you just said, or at least some of them, like list and maybe, I've recently learned like, hey, those things that you know how to use and have loved, it turns out those are monads. Try to think of them as monads now. But so you're telling me that list and maybe are also functors?
Yeah, because every monad is a functor.
Every monad is a functor. Okay, that's good to know.
Yeah, monad's just a functor with that like those two rules attached to it.
What are the two rules?
I think they're like wrap and roll.
Yeah, this is like a Greg's term.
Yeah, I guess that's Greg's term.
Yeah, I totally forgot for these Greg's lectures about monads. How they called monadic design patterns for the web.
Yeah. Josh and I were watching that video. That's the one I was showing
cool.
you.
Yeah,
like
I
a
remember.
month or two ago, maybe.
Yeah, that was helpful, and I saw that was on Channel 9. There's some Microsoft thing, and I saw another one called "Don't Fear the Monad" from Channel 9.
Yeah. This is like my favorite ones for explaining monads. And Greg was saying we have a monad, like this is a shape, this M. Then it says we have a wrap and roll. And this is a wrap, and this is a roll.
Yeah.
Okay.
So
wrap / pure, that just means like putting a thing into the monad?
yeah, exactly. And this is why I didn't like especially mention you have pure, because pure is coming from applicative, really, not exactly from the monad, but monads is also using this. And then pure is like a very simple. You just take the value and put it inside. If this is a maybe, this will be just, and if this is a list, it will be singleton.
Okay.
So
there's also return, right? I always thought of return as kind of like being the wrap.
Yeah, return is equal to pure. If you remember.
Yeah, I do kind of remember you saying that before, but I also in the back of my mind, I said to myself, well, there must be some different. Oh, wow.
No, because.
Does this relate to, does wrap and roll relate to map and reduce?
but not exactly. Map, they're really reduce for reduce. You need something more than a functor. You need some kind of way to traverse to be able to reduce something, because when you reduce something, you can return a different structure that you already have.
Mm.
Because when you're reducing list, you can return something else. You don't have to return list. And the functor and the monad, they are preserving structure. So you cannot change the structure.
Okay. Okay, so I've got another question for you here now, Tomislav. I see, like, starting on line 30 here, you're saying that this parser thing that we just made, because this is back when we were making our own parser from scratch, right? We weren't using the built-in parsec. So on line 30, you're saying, like, by the way, Haskell, our parser is going to implement, like, applicative. And so in order to do that, you have to define those two functions, right?
Exactly.
And then, okay, so then later on line 34, you're saying, by the way, our parser is also a monad. And so we have to define bind and return. And so it happens to be that for the parser, the monad return does the exact same thing as applicative's pure, but like pure is applicative vocab and return is monad vocab. Is that true?
Not only for parser. I can show you really.
But real quick, just to help me grasp on the basic things, is it true that pure is a word that is related to applicatives and return is a word that's related to monads?
Well, I cannot tell you for sure, but when they started in early version of Haskell, they didn't have this reference of monad with applicatives. They didn't have applicatives at all. I think later, I think they are put applicatives.
Oh,
and I think in version 8 of GHC, they made this connection with monad and applicative. This is like a big change.
Okay.
So before that, applicative was having pure and return, and monad was having return, and applicative was having pure. And now you have this dependency.
Oh.
Can I? No. What? Is this the source? You can see here that monad depends on applicative.
Oh. So, okay, so that's literally codifying what you said, that every monad is an applicative, right? Oh,
Exactly.
no, you said every monad is a functor earlier, but now we're also
but monad is also applicative, and applicative is functor, so every monad is functor. And you can see here the definition of return. This is
so
exactly
they're always the same. They're always the same. Is that what you're saying? They're always the same?
Yeah. They're totally the same, because what can you do with this kind of function? You have A as an input, and you must return MA. So you don't have too much choice to do. Okay. So yeah, and this was confusing to me in the beginning. Why this return? Why this pure? And especially, when someone tell you return and you're programming in Java or C#, you're thinking, oh, return. It's like a similar, but it's completely not the same.
Yeah.
And this is why Greg is saying we have wrap and roll.
Yeah.
because you have the structure, and the structure can be like a different. You can have different structure, and you implement wrap to just put the value inside, and you have this role to make a sequence of these expressions. You are combining one after the other.
Yeah.
And this is why the do is the do notation gives you a way to it's in the same sense like a weight to write nested this nested sequence of monads in the same nesting. It's just a syntactic sugar to so you don't have to write this bind. Does this make sense, or I can?
Oh yeah. Oh,
I
you're
can
talking
write
about
it.
do notation is just bind after bind after bind.
Yeah.
Yeah, I'm with you. Yeah, that makes sense to me.
So in the same sense, applicative or a functor is also almost the same. So
Okay.
a functor will be all just this, and applicative. I'm using the same m, like like parameterized for this structure, and applicative is this triple. So this is why I was telling you only about this. I was saying, okay, the bind is for monad, apply is for applicative, and map is for functor. But
Okay.
I was not saying, okay, you must have also a pure.
Yeah. Okay. All right. Okay. All right. So all that to say, you were about to use that $sign operator. What was that one called again?
Map. Or correctly, F map in Haskell.
Okay. Okay. That sounds
Function
more
is called
familiar.
Yeah.
So you were about to use that for parsing our nil, right? Because we're trying to get back a constructor tag that's not parameterized, but we did have to actually parse that string NIL.
Yes, and we want to parse this string and we want to map over it, but we don't care about like this result of this parser, because we know its result is nil. So
yeah, right. That's right. Because we told it to parse exactly one thing, so of course that's what it's going to parse.
Yeah, and maybe I can write it like this to be more clear. This is our nil, like a variable, because I'm defining an inline function, anonymous function.
Yeah, yeah. So Isaac, I don't know if you know the Haskell syntax. This is like lambda nil returns nil.
Yeah, and because I'm not using this variable, I can say, okay, I'm ignore it.
Yeah, okay.
So this is like an easy way to just ignore this parameter and give it the value. Mm-hmm. So you're not using this A, only B. So this is like B here. It's only A. You don't give the function, you give the exact value.
Mm-hmm. Okay. So line 42 is starting to make a little more sense to me. Line 42 is saying you take this function that takes in anything at all and always gives you back nil. And then you're applying it to this parser that's going to parse the characters NIL.
Yeah, in a sense, I want to apply this function to this parser. But this is like a parser structure. I cannot apply it directly. I must map over it.
Okay.
So you can think of this like you have a list of nil strings, and you must map over it. You cannot call this function directly.
Okay. Yeah, because it's a list, right?
Because it's a list, or maybe your parser, or anything else. But you know this parser is a functor, so you just map over it, and he will give you also the parser. You're calling the function with a parameter inside the structure and returning the whole structure. And this type, you can see it like this with parentheses.
What thing has that type?
This is the same type, but
What?
you don't have to specify parentheses.
Oh, sure.
Yeah.
But if you put parentheses,
that's the $ thing, right? That functor.
yeah, exactly. Sorry. Yeah.
Yes. Where is that F coming from? Like, what F is that it's referring to?
F is any functor.
F is any functor. Okay, but you're going to specify that at some point in time, right?
Well, in our case, it's parsec because we're giving it string. I don't remember what line we were on before, but string was.
For concretely for a parser, we can say, okay, if you have parser A, I will give you parser B, and now I can remove this constraint.
Yeah. Okay.
This is more general.
Yeah.
Because F here is a higher kind of type.
Yeah. Right. It's got a type variable that's a functor or whatever.
Yeah, and this is really very difficult for me to understand because in C# and in other languages you cannot specify this kind of F. In Scala you can specify it like this. F with like an empty type.
Okay.
So if you see this in Scala, this is higher kind of type. It's like this F, and they say, okay, this F is a functor. I think something like this. And if you have different effects,
What is the colon? Not cons anymore, right?
no, it's like a type. So you're
the type. What the hell?
you're saying this F have this constraints.
Yeah. Okay.
You can think of it like this functor. This F implements map. This functor means that this monad, this F implements monad, so I can use bind. And I just using this console that Pavel was talking about. If this F implements console IO function, we can use this function in our code. So you're just putting different effects on your this F type.
Oh, this F you're talking about now. This is something very R-chain specific, right? No? This is like what they're doing in our node, or this is something generally useful?
This is a style that Pavel was talking about. This tagless file.
Probably the R-chain core dev, right?
Yeah, exactly.
Yeah. Okay.
And
Cool.
now they're building like all the code in this style because it's a very nice way because this is what we are using here. We have all of these functions. We have defined functor monad applicative for our parser, and we can use all of these combinator functions that are not defined directly on our parser. They're defined in terms of a functor.
Okay.
Does this make sense?
Oh, a little bit maybe.
Yeah, so I'm just thinking about it like you were saying as like a higher order function or something.
But higher order types.
Yeah. Okay.
So I was thinking that this is very similar to mixing in JavaScript. You can say, okay, I have this F type, whatever it is, and you can call functions that are defined in functor and that are defined in monad or console.io, for example, here.
Okay.
You can use these function on this F type. In the same sense, like some kind of mixing that you are just putting, you have some kind of class and you are putting fmap function and you are implementing bind and you're implementing console for console.io.
Okay, all right.
Right.
So this is like implementing multiple interfaces in Java, like we're implementing F implements functor, monad, and console.io?
Yeah, exactly.
Okay.
But the interfaces are not hard-coded types.
Oh, they're not. Okay.
You must, when you implement interface, you must use concrete type. And you don't want to use concrete type. You want to use this, and don't know how to say this like differently.
Okay.
You want to
well, that's okay. I think like if we just keep sort of seeing this stuff in action, like, you know, it's really hard to understand an abstract thing when you've only heard the abstract version, right? So if we keep implementing our concrete parser here, maybe it'll start to be clear.
Yeah, and I want to show you how this function is implemented.
Yeah.
This one. Oops. So I think I can search functor and here. Oh, nice. So here's the function. And it's implemented just with fmap. And the const is just function to return always the, it's accept first argument and ignore it and always accept the first argument and this will be return value and then the next argument will be ignored. But I want to show you here, it's not important how it's implemented. It's implemented only with fmap function. It's a part of the interface in a sense. So if you implement functor, this function you will get for free. And this is the whole point.
Got it. Oh.
You implement only functor and you get all of these other functions already implemented for your structure.
So, okay, so when I declare that it's going to be a functor, that means I have to implement fmap. And then because this $sign thing is implemented only in terms of fmap, as soon as I define fmap, I get this thing for free.
Yeah, and a bunch of other functions. And this is the whole point.
Okay.
So hold the phone here. So fmap is like that, you know, angle bracket, $sign, angle bracket operator, except you give it a functor. Is that what's going on?
Oh, this one is just another name for fmap.
Oh, it's just another name. Okay.
Yeah.
But when you do it with only the arrow on the left side, then it's a little different, like you were just showing us. Can we look at that signature for?
Yeah, I'm not sure I understand what's happening with only the left angle bracket.
Oh,
there was something really helpful in your web browser. Oh yeah, there it is again.
Okay.
Yeah.
Okay.
So,
so they're using like a very point-free style. So you don't see like the real implementation.
Okay.
But I can implement it here.
All right. So it was fmap composed with const, right?
Yeah, exactly. So, but if you see it like in regular style, maybe it will be much clearer.
Okay.
So I have a function. This is like a first argument that I mean, first argument is A, and after that is FB.
Okay. I don't want to interrupt you, but I think I see what this notation means now. Maybe you can confirm it for me.
So I'm right.
So is this going to be like f map of const of a? Oh, wow.
Yeah, but I want to use only function. So I can say I will return a, and I will map over fb.
Oh, wow. So that dollar sign, that's just infix notation for f map, right? So that's the same as f map, a function that always gives me back a. Yeah, okay.
But
Over fb. So yeah, so like,
yeah, okay.
who cares what b was? We're not using it. We're just always giving back a.
Yeah, and we have a, and not the function. We have only value. We don't have this whole function. We only have return value.
Oh, so okay,
And,
so hold on.
and this one is really a const.
Okay, so const a means the function that takes in anything and always gives you back a. Oh, it just turns it turns a value into a function, basically. A function that always returns that value.
Yeah.
Okay, all right. I got you.
Const gives you back a function when you give it one argument, gives you back a function that always returns this first argument that you give. And all the other arguments that you give later is so this is why this combinator looks something like, you know, showing you what you want to return. You know, it's half of fmap.
Got it. Okay.
I remember it like this. So it's just pointing, you know, what because usually you have this kind of way of like forgetting the value.
Yeah, I think Haskell's funny to me because like, so we've got this function, this left arrow dollar sign, and it like when we read something that you write in it, like a couple lines above the top of the screen, we were using it, right? And it just looks like the kind of thing that must be syntactic sugar, right? Like that's got to be syntax programmed right in, but it's not. It's just a function defined in other functions, and it evaluates that.
Yeah, and for me, this is like beautiful.
Yeah, totally.
Because everything is function, and
all right, so I actually did appreciate that aside. I think I learned something.
This is also like a function, but on the kind level.
Ooh, I didn't know about colon K.
It's arrow. Yeah, this show you a kind of a type. So you can write the type in different way. This one is more complicated, but I can write plus. Oops. Oh, not. Oh. I can write it like this in a prefix type. Because this is type level function.
Yeah.
Oh.
So the first parameter is int, and like the second parameter is int.
All right.
Which means, you know, accepts int, and this is function. You know,
yeah. Okay, I see.
Wait, how does it know it takes two arguments though?
This is only one argument.
Okay, this is a plus that takes one argument.
Oh, yeah. Sorry.
Okay.
Or plus.
I mean, whatever. It's negator or something, maybe.
Yeah. Sorry. But this plus. How this is correct?
Why did that type check?
Yeah. Now I'm wondering also.
What do you mean? Didn't you just define something called plus?
Yeah, but he defined it in terms of that plus sign operator, which is int arrow, int arrow, int.
I think we have errors here, and this is why he doesn't show you I think, yeah, this language server cannot build the whole project, so it's using the old build for displaying errors and everything. So this is definitely an error.
Okay.
Yeah, I should use something like +5 or something.
Oh yeah, all right.
Yeah, good point, Isaac. Yeah.
Cool.
Oh,
Okay.
I was showing those.
Yeah, cool. Okay, cool. So
This
let's
is
maybe in our last couple minutes, let's refocus and see if we can, does our nil parser work, or maybe we should write a test for it or something?
Okay, yeah, we can use this version. And what we are missing? Oh, we have some definitions here which are definitely not good.
Yeah, we didn't need that +5 to parse row calc.
So we have proc, we have proc m, which will be a little difficult to to write in this style, because now I don't know how to write in a nice way.
What does proc m do again?
It's the same in the monadic style. With
So you wrote it, yeah, right. So you wrote it on line 41 in the applicative style. Now we're thinking about how to write it in the monadic style. Oh, and it's tricky because of that or combinator.
Yeah,
right?
and this or. I think we need like a separate function and say something like.
Well, should we just ditch the monadic style or?
Send. Oh, what? Send and this same nil parser, but maybe we can extract. Yeah. I must write the type. I don't want to say proc, but I must. Because this is not the completely correct. I'm saying this is a proc parser, but I'm parsing only nil.
Mm-hmm.
But okay for now.
Wait, so we're trying to get nil off of that line there? Oh, I see. Okay.
Wait, why don't you like saying parser proc there? It does parser and give you back a process.
Yeah, but I'm parsing only nil, so I'm not very. I don't like this because it's not really. This parser does not handling other case. It's only using nil.
Mm-hmm.
So
Well, I totally agree with that, but I don't see why it's a problem or what makes you uncomfortable with it. Like we could do the same thing right after that. We could write like send has type parser proc and then send equals, basically what's on line 43. And then we could do like parser proc, we could do proc has type parser proc and it equals send or nil with that applicative or.
can you please repeat? Sorry.
Yeah. So like on 38 and 39, you separated out our nil parser, so it's its own thing there, right? I'm saying, like, what if you do the same thing for send? So you have like, on line 38, you have nil has type parser proc. What if on line 40, you put send has type parser proc, and then send equals all that junk that is currently on 43?
Mm-hmm.
Without this case.
Yeah, exactly. And then 43 becomes, okay. Yeah, bingo. And then, that's what I was suggesting. Now you have to tell me whether that makes sense or not.
Well, yeah, I'm thinking that it's completely correct, but I'm thinking, is it okay to say I'm parsing proc, but I'm only parsing one? value. But on the other hand, yeah, I'm saying I'll only parse nil because I'm nil parser.
Mm-hmm.
Yeah, it makes sense. Yeah, yeah.
I don't have any context to know whether that's like good style or something that people would like. You're my context. for that.
Yeah. You're right. You're right. It seems okay.
Okay. All right, cool. I don't see any red lines.
Yeah, for compiler will definitely compile this. I'm just thinking that you're saying I'm returning parser for proc, but I'm only parsing. I will really only parse and
Some
return
subset of
some
process.
subset of this type. So
Yeah.
maybe I'm wrong. So yeah. So yeah, and I want to do the same thing here, where and now we have. Oh,
Oh, that was cool.
so we have now everything right, and we can
Wait, did we do the nil parser monadically?
Well, we can do it, but yeah, it's trivial.
Yeah. Okay.
But
Oh,
I
but that
will
might be
write it down.
a good exercise for us.
Yeah.
So,
Yeah.
okay. So nil m equals do. Oh, do.
So
Don't tell us yet.
so we definitely want to use this string parser, and we want to return this nil.
Yeah. So okay. So I think it's going to be something like an underscore from string nil. Like we want to parse string nil, but we don't care what we get back.
Yeah.
And then I want to say return nil, but maybe it's pure nil, or maybe it doesn't matter.
No, it doesn't matter.
Okay.
We can use return or pure. But I need the type.
So why did you have to do that? It couldn't infer the type?
It's ambiguous type.
Return nil should make the proc part unambiguous, right? It's ambiguous whether it was a parser, I guess.
But it's not a problem with the return type. The problem is these two variables. If you remember from the last time, this is our string.
Oh.
So he knows for proc, but he doesn't know S0 and M0.
Okay.
And I think you can use some kind of extension to just ignore this kind of stuff. But I'm not sure. But
okay. But your type annotation fixed it, right?
Yeah, because I'm saying this M and S will be completely these types. Identity structure for M. I think M is for that, and S for stream is a string, and he doesn't know that from the result. I think that's why he doesn't know these two arguments. And when I say I'm using parser, I'm specifying these two types because parser is defined concretely with these types.
Gotcha. Okay. Oh, I get it. So proc wasn't the problem. Parser was the problem.
Yeah, the compiler.
Yeah, okay.
So parse. No. parser function. So the type parser is this is not the
Parsec
correct
string
parser.
unit.
But this doesn't seem to be correct type. Oh, this is the correct type. No, this is like a parser T. Oh, we need to see this parsec, which accept these two types. Because the initial structure is parsec T.
Parsec T is the SUM thing, and so they're showing that M is identity here.
Yeah, M is an identity, but S and U is still a parameter. It's just a, these types defined in terms of this one and this one and this one. And the latest is this parser, which is defined is in terms of parsec. And this S is string, and this unit. Another type is unit, which I don't remember what it is. Okay. So we have this very simple type that is only parameterized on the result. And this is why we can just say this parser of this type.
Cool.
But if you look at the type of this string parser, it's like a totally complicated. Although now it's showing us the concrete type, not the general type. You see here, this is
yeah.
Because it's showing us what is the type inside the function that we have defined, not the general type, the real type, which is also cool. You can see how it's what is the type in this function.
So all right, so hey Tomislav, this is a little bit of a aside, but I'm looking at lines 32 and 33 right now. So I don't think you have to be worried about on 38 and 39 where we said nil has type parser proc, but it doesn't parse all processes. Because look at 32, exclam has type parser char, and it doesn't parse all characters.
Yeah, you're correct.
Okay, cool.
When you said all of these things, I'm thinking that you're right.
It feels trippy though, right? It feels weird. But okay, so let me ask you this question: how do we? So I want to just test if we can parse nil correctly, right? So we've written those two parsers.
Yep.
How do we do that again? Because that's what I couldn't remember on my own, like how to actually use this thing.
So we are running. We have a run function that accepts our parser and accepts string as an input. So this should parse nil also. But I don't see. Oh, I didn't load our parser file. I didn't import it.
That wasn't in the dependencies. So when you did stack.
No. You can see it here.
Oh yeah.
What is the exposed modules? So this file is generated, but I will modify it just to show you that if you run REPL, which file is here first, it will be included first. Oh, there is a warning. Okay, now he load all the files.
Oh.
Usually it loads only the first one, but maybe there is some kind of different logic.
Okay.
But definitely you can see exposed modules here, which you must define in this compile file. So now we have run. Our proc parser can be this applicative version, and we can say nil. And we have error.
Unexpected end of
Why?
input. Expecting letter, digit,
Let's
underscore.
let's try just nil. Okay.
Okay, good.
Yeah.
So where did we define proc? Send or nil? Well, it definitely doesn't parse as a send, that's for sure, but it
Yeah. But it should parse a nil.
yeah, and it did parse as a nil. What if we try proc M?
It shouldn't be different.
Same error, yeah. So I'm, you're gonna see my newbie-ness as I just flail for solutions here, but I'm just curious if we change line 50, if we change the definition of proc to be like nil or send, I'm curious what happens then.
Yeah, it will work.
So it seems like almost that or combinator isn't working, right? Is that a combinator? Is that the right word?
Yeah. They're saying combinator operator.
Okay.
I think it interchangeable.
So we have to reload, right? Oh yeah, okay.
But only proc.
Oh, now it runs.
I'm thinking that this alternative operator should be implemented in a way that it parses the first parser, and the first parser is like a fail. Then it should start parsing the other one. I'm not completely sure why. Maybe we need some. Maybe we need to tell him that we are expecting end of string. I'm not completely sure.
Unexpected end of input, expecting letter, digit, underscore, single tick, or back.
It's
Well, this
saying
sounds
that
like a decent homework
expected
assignment.
send. Sorry?
This sounds like a good homework assignment.
Yeah.
Do you want to pause here and then we'll
I'm okay.
We'll figure out what the problem was and we can all debrief on that.
Yeah, definitely. I will look into it. Yeah.
I will too. I think it'll be, I got to pull some weight here too. You've taught a lot already. I need to start stepping up. So this is a good thing. All right, cool. Well, Tomislav, as always, man, thank you very much. And, I have this hope of a future where I can write a Rholang interpreter and you're making that a reality. So thank you very much.
Oh, cool. Well, I'm planning to like free some time and like be more with the Rholang and.
Cool, man. Yeah. So do you have a day job, Tomislav, or what's your situation?
So now I'm in the middle of like between jobs and so.
Yeah, cool. My friend Shannon uses the term "fun employed," where you're enjoying what you're doing in the meantime.
Yeah, exactly. Yeah, but I have some older projects and I want to like finish and
Yeah.
Now I'm playing with the Raspberry Pi. So.
Oh, cool.
Totally different topic.
Yeah. All right, cool. Well, I guess I'll see you guys next week.
Awesome.
Yeah, sure.
Thank
All
you,
right,
Tom.
great.
Thank you for a Casper stand-up.
Yeah. Hey, and Tomislav, you can push this, right?
Oh yeah.
Awesome.
I will just check the syntax errors.
Yeah. No big hurry or anything, but yeah, cool. Isaac, can I swing by your place for a little Bitcoin swap?
Oh yeah, sure, man.
Cool. All right.
So
Bye, everybody.
should I post both videos or just the Casper?
I'd say both probably, right? Are you guys okay with that?
Oh yeah,
Yeah.
definitely.
Awesome.
I hope it will be helpful.
What was that?
I hope it will be helpful to like.
Oh, totally. Yeah, I love having them online too, because we learned a bunch today, but I'll learn more when I go back and review this too.
Yeah.
Yeah.
Oh, cool.
All right.
I'm glad.
Thanks, everybody. See you next week. Thanks for
Yeah.
the videos and room and everything, Jim, again, as always.
Yeah. If you don't have admin in the Divi
Divvied out.
Yeah, I do.
so you can fill in notes in the descriptions.
Right.
Awesome. Yeah, Isaac, you've been doing a good job on that, right?
Yeah, for the most part. I don't think I did anything last week. But other than that, yeah, I've taken care of most of that.
Cool. Cool.
Yeah, I did see some stuff. Thanks, Isaac.
Oh yeah, absolutely.
Yeah.
Yeah, thanks.
All right. Bye, everybody. This was
All
fun.
right, guys.
Bye
See you
bye.
later.
Yeah.